not every function has vertical asymptote. Not every function necessarily has a horizontal asymptote. Okay? Horizontal asymptotes are determined by the degree of the numerator and the degree of the denominator. Alright, so vertical asymptotes look this way. Alright? Horizontal asymptotes. Alright? We can have multiple vertical asymptotes. You can have more than one because for every zero you have in your denominator, you can have an asymptote. But for horizontal, we're only going to have one if we have one at all. Okay? If we have one at all. So let's just say that you have a function, and I'm going to call the numerator function n and the standing m. And we're going to be discussing their degrees, okay? If the degree of n is less than the degree of m, alright? So the numerator is smaller than the denominator. We have a horizontal asymptote at y equals 0. Do you know what HA stands for? Y'all are a really smart group. I enjoy this class. You're so smart. So, an example, the degree of n is less than the degree of m. See that? 4 is less than 5. You can add other stuff back here behind it if you want. But the degree is less. Okay. If the degree of n equals the degree of m, you have a horizontal asymptote at y equals the lead coefficient of n over the lead coefficient of m. I'll let you get that written down. I'll show you. That was a little bit harder to get. Alright, so I have 4 and a 4. They're equal. So I have a horizontal asymptote at y equals 32. Oh goodness, it's so easy, right? Yes, no? It's not easy? Alright, so we've done less than, we've done equal to. What's next? What's left? Greater than. If the degree of n is greater than the degree of m, no horizontal asymptote. Not a horizontal asymptote there. when we begin to make a note card, I will let you put this on your note card. This is note card material. We're not going to make it right now, but when we make a note card, this will be on there. You're welcome. All right. Find the horizontal asymptotes of those three rational functions. G of x, what is it? Y equals 4/3. Don't forget, now this is something to watch for, especially on the test. On vertical asymptotes, it's x equals. On horizontal asymptote, it's y equals. If on the test you just start listing numbers, I really don't know if you know what direction it's supposed to be going. So you're not going to get your credit for it. Like if you just say, oh, 4/3, 2, and 7. Okay, which ones are which? Like I don't know. So you have to let me know y equals or x equals. All right, how about h of x? What? None? Why? Okay. And here's something else on the test. When there is not one, you need to write out none, no, not one, doesn't exist. Something to show that you didn't just skip it because you can't find it. Because like a lot of people skip stuff. When they don't know how to do it, they skip it. So I'm left thinking, well, did they really not know how to do it and that's why they skipped it? Or did they really know how to do it and they knew that one didn't exist, so they left it blank? So every single blank, usually on this test, there's a chart and a graph to the side. And you fill in the chart with everything that you have to have, and then you put the graph on the side. So if you leave things blank in the chart, it's not wrong. Because I want you to tell me that nothing is there, or none, or it doesn't exist, or something. So I know, oh, they didn't just skip it because they don't know what they're doing. All right, how about q of x? Does it? Why? All right, great. All right, good, very good. Okay, so horizontal asymptotes, pretty easy, right? Yeah, yeah, yeah. Okay, we're gonna talk about one more, and then I'm gonna let you work on your stuff. Slant asymptotes. So vertical asymptotes are vertical, horizontal asymptotes are horizontal, and slant asymptotes, slant. Yeah, it's crazy like that, right?
Those big words in
I know. Like that stuff. Alright, so a slant asymptote happens when the degree of the numerator is exactly one more than the degree of the denominator. Okay? Degree of the numerator is exactly one more than the degree of the denominator. Can you have a slant asymptote and a horizontal asymptote in the same problem? Why not? Right. Remember, back here, when the numerator's degree is greater than the denominator's degree, we don't have a horizontal asymptote, okay? When it's exactly one more, you'll have a slant asymptote. Let's look at this. Do either of these have a slant asymptote? No, they do not. So, how do you find the slant asymptote? Well, it's funny you should ask that, right? You have to use long division. I know you're all super pumped about that. I know, right? What? Alright, to find, okay, first of all, this has a slant asymptote. How do I know it has a slant asymptote?
Because it's 3, 1 degree higher.
It's exactly 1 degree higher, okay? To find the asymptote, you just do the division. Now, we can't use synthetic division because that's not linear. You have to use long division. But the good thing about it is we don't care about the remainder so much, okay? So this is x squared plus x plus 3 going into 2x cubed plus 5x squared plus 0x plus 1. What times x squared gets me 2x cubed? 2x. Now this gets multiplied by everything here. And then what happens to all these down here? Those cancel out, and I'm left with 3x squared minus 6x plus 1. Okay. What times x gets me 3x squared? What times x squared gets me 3x squared? 3. So make sure it cancels out, and you're done. Okay, there is a remainder, but this right here, y equals 2x plus 3 is your slant asymptote. Like, literally that is your asymptote. You would graph that. Remember how to graph a linear function? Go up 3, that's your y-intercept, then up 2 over 1. That's your slant asymptote, right there. Okay? That would be your slant asymptote. By the way, also, how you can get a slant asymptote, how to get it, like when it happens, can also go on your note card. This sort of thing cannot go on your note card. So when we get ready to make your note card, the degree of the numerator is exactly 1 more than the degree of the denominator can be on there. Use long division, can't be on there. Okay, just the definition part, no real math stuff. Okay? Alright. Any questions about any of the aspects? Because we're going to do all of them at the same time now. I'm throwing them all at you. Got in the bag, I'm going to toss them out. No? Okay.